Okay, this is the third example from the handout on Tuesday, week 6B, applications of quadratic functions. This is maximizing profit. So the price demand for bouncy balls is P equals minus 0.02 x plus 5, and where x is in thousands and p is the price per ball. So we want to give the revenue function. So that's part A. So revenue is x times p. Oops. So x times p. So we distribute the x to get minus 0.02x squared plus 5x. That's A. The next question is if cost is given as 1.65x plus 10, find the profit. Now profit is revenue minus cost. So it's the money that comes in minus your bills. And so our profit, well, our revenue is minus 0.02x squared plus 5x minus 1.65x plus 10. Now don't forget to distribute the negative. And so we get that the profit function is minus 0.02x squared plus 5x minus 1.65x minus 10. We can combine those two terms to get minus 0.02x squared plus 3.35x minus 10. So the next question, what are the break-even points? So the break-even points, that's where your profit, that's where your revenue equals your cost, or your profit is 0. So since we just found the profit function, let's use the profit function. Okay, so we take that profit function, set it equal to 0. It's a quadratic equation. So we're going to use the, well, now we could use the quadratic formula. But you know what? Let's use our calculator today on this one. This one's a little bit harder than some of the others that we've seen. Lots of decimals and stuff. Okay, so we're going to go to our graphing thing. We plug in our profit function. Whoops, not what I wanted. Minus 0.02x squared plus 3.35x minus 10. Now, let's see, I'm going to graph it and see what happens. Yeah, okay. I need to change my window. The x isn't valid less than 0 because it's items. It's kind of hard to know what to make my y, but I know this little trick where if I look at my price demand, and it's linear, and I take the 5 divided by the 0.02, I get 250. So that's what I'm going to use my my x max as. I am going to use a scale of 25 My fixed costs are -10, so -15 is good. I don't know what my maximum's going to be. Let's try 50 and we can go from there. Oh, 50 is way not high enough. So let's make it 150 for our Y max. So there's some science to figuring out your window, but a lot of it is guesswork and just trying to play around with it. All right, so there we see our profit function. That will be our maximum profit in a little while, but what we're looking for right now is the break-even point. Now let's see. I'm still not real happy with that window, but I'm going to do the Y scale should not be at 1, so I'm going to change the scale to 25, so I'll get some little tick marks. It makes the axis not as thick. Okay, there's one break-even point, and there is the other. So to find that break-even point, go second calc, go down to 0 because break-even points are zeros of the function. I want the left bound. I could use the arrows, but I can also just type in. And I know that this 0 that's over here occurs to the right of 0, x equals 0. So my right bound, or my left bound was 0, and I'm going to use the arrows now till I am to the right. And there we go. My first break-even point is x equals 3.040. So x is in thousands. So about 3,000 bouncy balls is my break-even point. I need to find this other break-even point. So I go back to calculate, choose 0. Now it wants to know my left bound. So I'm going to use the arrows this time because I don't really know what values to type in. Whoops, too far. Okay, so I am to the left of that break-even point. I press enter. That's the right bound, so I move to the right and press enter. And it wants a guess. I just press enter again. And there we go. 164,000 is my other 0. So 3,000, roughly 3,000, and then 160,000. And anyway, so roughly. So when you write that down, you may need to take some decimal places depending on the directions for entering your answer. Okay, the next question is, what is the maximum profit and what's the number of units we should sell? So I go back to my calc menu and I'm going to select maximum. Okay, it wants a left bound. I know it happens between 0 and a right bound. How about 165,000? Don't do that right now. Oh, come on. Don't crash now. All right, so the calculator is quite grouchy. So you would enter the right bound, and then you would enter a guess, and it would give you the maximum. So I'm going to switch to the formula and do minus B over 2A. So that's going to be 3.35 divided by, or minus 3.35 divided by 2 times minus 0.02, and it's 83.75. All right, so the break-even point was at x equals 3 and 164.46. Those are the two break-even points. For the maximum profit, we need our vertex HK. H is minus 3.35 over 2 times minus 0.02, and that works out to be 83.75. So that's the number of balls we're going to sell. So to figure out the profit, I take the 83.75 and plug it into my profit function. And it would be a lot easier if we could use the calculator, but I don't want to have to restart it and everything. So we'll just do this. And just type it in. And 130. And so that's dollars. So that would be $130,000. Okay. One last question. Okay, so the maximum profit is going to be $130,000, and we're going to sell 83,000 bouncing balls. The last question is, what is the price we should set to maximize our profit? So if we set the price too high, we won't sell very many, and we won't make our maximum profit. If we set the price too low, we'll sell more, but we still won't. Our revenue will still be smaller, and we won't make as much as we could. So to find that, we take our price demand function, and we plug in that H that we found on the previous screen. So that's what we plug in. And it's $3.33. Well, it's $3.32.5, so we will take that to be $3.33 per bouncing ball. So the story is, if we set our price at $3.33 per bouncing ball, we will sell 83,750 bouncing balls, and our maximum profit will be about $130,000.